This is Ayesh. Today I'm going to give you all the technical BS out there, an understanding of the APIs and how to document and why and where to use them. So this one is going to be all about APIs. So without further ado, let's get into it. Cool. So what is an API? API is just connecting two systems together. So by the end of this session, you would know what you need to know as a technical BA for integrations and API work. As a senior BA, technical BA, or just an analyst, think of yourself as a translator between the business needs and what the API must give you. It's simply in plain terms, it simply allows one system to talk to another system. So imagine if you go to a restaurant to order some food, and then you sit at the table and the waiter comes through to take the order and then goes back to the kitchen with the order, comes back with the food. So the waiter would essentially be your API, whereas you is the customer and the customer application or the front door. Waiter would be, in simplest terms, would be the API who brings you food and do all the coordination with the kitchen and yourself. So that's the gist of it. Let's move ahead. We have seen a couple of terminologies in those APIs, designing APIs. One is REST and one is JSON. What you should know here is REST is simply a style for building APIs. It defines how requests should look like. We use some methods. For example, REST APIs use HTTP method. If you have seen in the browser, when you are surfing the web, you can see http:// so that's one method that we use to get all this information. So it's REST API services. When someone says REST APIs, there are certain methods that to get data. So REST simply says how to structure the data and how the APIs should be structured. So for example, if you see somewhere saying get customer/customer data, it means read the data and retrieve the information from the customer table. If you see a post, it means create some data. Put means simply update the data. Delete means delete that data from the backend. So that's the easiest, simplest meaning of REST. It is the structured way of defining how to structure an API. And then you see some people referring to JSON. What is a JSON? It's a JavaScript object notation. Just do not look into the terminologies. What you need to understand here is basically it's the format that the API is used to send data. So think of it as a structured text format for data. For example, if you take the road and you are on a vehicle, the road is your REST, because that's the pathway that you are getting to, structured pathway that you are getting your vehicle on. If you have a vehicle and you have things inside in your vehicle, those stuff that are inside your vehicle becomes the JSON. Let me know if you can understand all these analogies, but then it's basically a simply data in a presented in a structured way. For example, name followed by full name, email, and the age. So as you can see here, the examples that I have taken is just some customer data followed by the field name, and this is the value, field name, value, field name, value. So when you send a request to an API, you usually use a JSON request. When the API replies, it also sends you back a JSON request. So that's the response back to you via the API. Those are the two things that you really need to understand here. Those are the two terminologies as a technical BA that you need to understand. The next one is always everyone asks about this on what is the difference between REST and JSON. REST is pretty much the road rules, and JSON, as I said earlier, the vehicle that carries the stuff, carries the information. I have given you a brief on what sort of a role in an API, how both of them, REST and JSON, what role they play. Think of it as the rules of the conversation as REST and the language used in conversation as JSON. So that's simply as that. Let me know if this confuses a lot of you, but this is the most simplest form that anyone could guarantee that you have the best understanding as a technical BA in this space. Let me know in the comments. Let me know how it goes. Now let's move into the next section. This is getting interesting as we go on and getting into more technical depth as I can provide you the best information that I can simplify things and let you understand. Alright, so most often technical BAs are equipped to ask to document the APIs. So this is the purpose of this is why we are doing this. Why we are doing the API documentation is to give the developer to use the API. They need instructions. That instruction manual becomes the API documentation. Without documentation, developers would be just guessing. That's why we have a tool called Swagger. I can't remember the brand name, but Swagger is a place that we put all the API documentation safely and then may it be public or private. We can manage it there, do amendments, and then follow and clearly see what's in an API. I will provide a simple technique maybe in another video where I do a Swagger API documentation in real time, develop it for an inventory, and then show you what are the endpoints that I'm using. So that's for a next video, but this is very high level as to what technical BAs can understand from APIs. Alright, let's move on. What is Swagger? So that's what I've just informed you. Swagger uses a format called OpenAPI. OpenAPI is simply a structured file that describes the API. For example, OpenAPI.yaml. So that's the notation that Swagger uses. We are able to edit into it, do more updates on that, and then publish. So it's more of an interactive document where developers can see and then see endpoints, examples, and we can even use it to try and do some testing on that with some sample API calls. Right, this is what I'm not going to do today, so I'm going to skip it and then have another tutorial coming up for this. So let me quickly skip to the other one. This is all about how to create response and post endpoints. Yeah, so I'll get down to the common API authentication methods. So remember, when we are sending information via APIs, they can be intercepted and hacked as well. So I have seen numerous occasions where APIs are hacked, and then in between you send some more information, fake information to hack systems. So we use authentication methods to improve the API security. There are some really well-known API authentication methods like API keys, basic authorization or authorization 2.0 using tokens and the JWT tokens. So I've given you how each of these works. So API key is just simply a key included in the request header. When it's internal or a simple API can be used. Most of the legacy systems use basic authentication, and OAuth 2 is the new one, which is they are in the public platforms right now. So it is like a token issued by the identity provider. So if you see a public API somewhere, it would probably need a token given by the public, given by the creator, so you can use it in your applications. That's how most of the open API that I've seen in the World Wide Web works in public platforms. So OAuth 2.0 is something that you would need to understand. And then we have JWT token, signed token, proving identity. So in that same token, we are proving identity as well. So modern microservices uses this option as JWT tokens in their APIs. I will tell you a little bit about microservice in the next couple of slides. So that is adjacent to APIs, and then it's really good to have that understanding of microservices. So for now, authentication methods, these are the ones that we commonly use in APIs, so best to know these ones as well. Right, so then it comes to APIs, there are a few integration patterns every BA should know. In my understanding is technical BAs must understand how systems exchange information. So there are patterns that they need to understand in a very high level so that they know what's going on with within the system. First thing is request and response. System calls system B and waits for a response, and then gets a an response back. So that's called synchronous as well. So it's for an example, it's basically checking a customer details during a checkout process on a website. So it basically validates with the customer table via an API. So that's system A, and then system B is validating that back into the front end. So that's a request response behavior which is synchronous. The next one is event driven. So one system will publish an event and other systems reacts to it. It's not proactively looking for that response back. So we call that asynchronous. So for an example, when we place an order on Uber or any other platform, it triggers shipping and then triggers an invoice. So all this order placing will create a trigger into the database to create the shipping documentation plus the invoice, which is then sent to the customer. So that's most of the time an event driven confirmation, because one system really publishes it and that there's a trigger event that triggers the API to go and do the rest of the work. We also have something called batch integration. Mostly on enterprise data driven companies, the data is moved into scheduled batches. So these batch integrations are like really complex, but once you understand it is a batch integration, you should understand that there is a scheduled batch process that will be running via the APIs. So for an example, nightly payroll data transfer. So you have all those banks and all those enterprise systems. You have a lot of data sitting in throughout the day, and there will be a scheduled batch process that is happening for data transferring into other systems. So that becomes a batch integration process. And then we have webhooks. So usually used for payment services and then payment systems where instead of polling for data, system pushes updates automatically. So that happens automatically. So for example, Stripe notifying your system that a payment has been succeeded is one of the webhooks that they use from Stripe APIs to their backend and then to you as a customer. Sometimes you can argue that webhooks are the same as event driven asynchronous, but then this is a slightly different area where we do not have polling for data. Now here when it is event driven, there's a polling of data on the order that triggers shipping and invoice, but here it is updates going automatically. There's no polling for data. The updates are pushed automatically. Hope that clarifies. But then there's a data sync and data replication. This is the final part on system integrations. Two systems maintaining same copies of data, could be a disaster recovery site or could be another analytics platform from places like Salesforce. So we sync data via APIs, and then that becomes a part of the system integration. What you would need to know, must know at this stage as a technical BA is all these ways and patterns how we integrate with each and every system. That is a must. The what and how to do that may largely sits with the engineering team, but there's no in my experience there's no real urgency to cover those on how to do it and what are the specifics of it. But it is good to know the system integration patterns in advance in your technical BA career. Right. So I wanted to give an understanding on the API architecture that is widely used. One is if I take a example of a food ordering process, which I took earlier as well. The part of the system, there are 4 parts of the system. You have one side the client, the app that you are using, and then there's something called API gateway. So it's basically the front door that receives your request. It's simply if you think of going to restaurant, you pick out a menu from the item and then you press the order pizza on your phone or the device that you are using, and then API gateway is the first receptionist that you receives the order, and then okay, this is the order, and you are the customer, validates that, and then sends that to the API service, which is the logic that processes the request. So it's similar to the chef that prepares your food. And then database is similar to your kitchen, where the ingredients are kept and the store information is kept as well. So if we look at a layered outlook, the app is where you send the request, API is controlling the access, service is running the business logic on top of that, database is where the data is stored. I wanted to touch base on microservices, what microservice architecture means. I would go ahead and create another system design workshop or a video on this, but what I wanted to say is, like, we learned about APIs and integration patterns and how this API architecture goes into microservice architecture. So microservice architecture, I'll take an example. Imagine a supermarket having different departments. So the supermarket will have different departments where they have different databases to take information. They can work independently, but then they can coordinate via the API gateway to your client app, to you, or any other backend operations to provide that information. So in a summary, microservice just means many small systems working together. So that's the Microsoft microservices architecture. Sorry, I'm not going to tell about brand names here, but microservices architecture is simply a set of departments working together to get you the necessary information. I'll probably do another video on microservices architecture, not a little bit of going into details into that as far as technical BA is concerned. But this is where we stop. So what we have gone through today is, we went through what an API is, what are the types of APIs, what are the integration patterns of the API. I'll do another video on Swagger on how to create that API and then publish it, as well as a microservices architecture. So thank you for staying with me, and then if this is helpful, comment or put a thumbs up and subscribe for more videos like this, and you'll get more value. And if it is valuable, just share it on your social media and let me know I am out there. Thank you so much for staying in. I'll see you on the next one. See ya.